Now we'll discuss the flow characteristics of the control valve. This is also important parameter for selecting the control valve. So you have to size the control valve, and based on the sizing you have to select the valve, and in the selection this flow characteristics plays an important role, because based on the flow characteristics, so your parameter is which parameter is to be controlled is decided. So different types of flow characteristics are there. These are theoretical. Actual flow characteristics based on the actual selection of the valve, that is slightly different from these characteristics. Those are called installed characteristics or actual valve characteristics. So in this we will see what are the types of characteristics. What is a characteristics? It's a relationship between flow coefficient, that is flow capacity, versus the valve travel. So as valve tries to open, valve opens, how the flow changes through the valve. So if it is a linear, it is perfectly changing with 50% travel opening. So rated flow is also 50%, that is nothing but flow coefficient 50%. If it is a 75% travel, 75% flow, that is a linear characteristics, which is very rarely we will get, but exactly will not get exact linear. This is theoretical, because it is impossible to get exact linear, because it depends on the geometry of the components, valve components inside the valve. So but however still it is a linear characteristics we will use for certain control parameters that we will see next. So this is a linear characteristics. Then we will have quick opening characteristics. So nearly at 50%, 40% travel, almost valve opens to 70%. So it's a quick opening characteristic. So as at 50% itself, valve flow is nearly 80% flows goes through the valve. So that is called a quick opening characteristics. This is mainly for on-off applications. On-off applications. So it is called quick opening characteristics. So at the beginning itself it opens and allows most of the flow. So another important is equal percentage characteristics. For most of the control parameters, we'll use this type of characteristics to the valve, to the control valve. Equal percentage. So because it matches with the most of the parameter, control parameter characteristics or reaction rate, it will be suitable for the most of the parameters. Equal percentage. So that means below 50% travel, the flow is gain is less. Flow is changing slowly. At more than 50%, the gain is double almost. So the flow is increasing very fast. So that is equal percentage. So here percentage changes from 20 to 30% valve of a valve travel. The change in flow is very less, maybe 0.5, maybe 5% only. 5%. That is a gain of 0.5. So at higher percentage, maybe from 80 to 90, that is 10% valve travel, and the percentage of increase in flow is almost double, that is 20%. So what is a gain? This flow by valve travel, that is 20% by 10%. So gain is almost 2. So like this, this gain will be changing as we valve travel opens, travels towards the maximum side, 0 to 100%. As it travels, the gain also increases. So this is called equal percentage. So this is mostly suitable for most of the applications for the throttling type of control valves. So so while selecting the control valve, after sizing, you have to select the characteristics also. Then only you can find a suitable control valve for your application. Hi. Now we will see the flow characteristics and the how it for which parameter which flow characteristics you have to select. That is a flow characteristics selection guide. So for pressure, what are the flow characteristics? Flow pressure control. So in a pressure control, we have to see the dP maximum to dP minimum ratio. If that is greater than 5, you should go with the equal percentage characteristics. This is a thumb rule. So ratio of dP maximum to dP minimum. If it is greater than 5, go for equal percentage. dP maximum to dP minimum ratio is less than 5, go for linear characteristics or large volumes. So in such condition, you should go with the linear characteristics. For temperature, always you should go for equal percentage, because temperature is a slow changing parameter. So here, that's why they will go with always with the equal percentage characteristics. Flow control, equal percentage unless wide range of set point changes are there. Normally we will go with the equal percentage for flow also. Level also, there is a certain condition, ratio of dP maximum to dP minimum greater than 5, same like pressure, they will go with equal percentage. If dP maximum to dP minimum ratio is less than 5, you will go with the linear characteristics. So these are roughly the selection guide for the control parameters, flow characteristics in the control valve. So while selecting the control valve for which application, you have to decide the type of characteristics. So selection of valve depends not only on the sizing but also on the flow characteristics as well as leakage class that we are going to discuss next. Now we'll decide the basic valve selection for CV. So after calculating the CV, we have to calculate it 3 conditions: maximum, normal and minimum flow conditions. Of course, by using the formula as we discussed earlier. Now with these 3 CVs, we should go look at the manufacturer catalog to select a valve with the following CV requirements. So this is in the manual selection. If it is a software selection, it will suggest you, it will provide you options of different valves that we will see in the valve sizing operation lecture. So in this condition, CV required at maximum flow, so it should be 90% of rated CV at the selected valve. So CV maximum shall lie at 90% of the rated CV of the selected valve. As I discussed, whatever we are calculating the CV is a required CV, that is theoretical CV. So 90% of rated CV of the selected valve, this is a valve CV. So already developed and fixed by the valve manufacturer. So again, CV required at normal flow should be around 50% of the rated CV of the selected valve. Similarly, CV required at minimum flow should lie at 8 to 10% of the rated CV of the selected valve. So this should be our criteria for the selection of valve. for our calculated CV. These are the calculated CVs. These are the installed CVs or selected CVs of the selected valve. So they should match accordingly to this. Exactly, they should not match. You have to optimize according to these conditions. Maximum CV at 90% of the rated CV. Normal CV, required CV should be around 50% of the rated CV. Minimum CV should be around 10% of the rated CV of the selected valve. That should be the criteria for the selection of the valve. So valve selection depends on the leakage classification also, seat leakage classification. This is a mechanical requirement, but still we have to understand what is a seat leakage classification. How, when we are selecting the valve, so you have to select the leakage class. This is that is called ANSI class. So which class you have to do? You have to select even in the software, sizing software, or manually also you have to select. So what is the meaning of this maximum leakage? How much it is allowed here? What is the medium? What is the pressure and temperature conditions given here? So seat leakage classification, FCI class shut-off ratings. Shut-off, it is also called shut-off classifications. When valve is fully shut off, so how much leakage is allowed? So that is classified according to this selection. Class 2 means it will allow 0.5% of valve capacity at full travel. Air or water medium. So this is a 0.5% is allowed. This is a simplest type. So if it is a class 3 requirement, it is only 0.1% valve capacity at full travel is allowed. Only 0.1% is, this is very severe. So the severity increases as class increases. So class 4 means 0.01% valve capacity is only allowed during shut-off. Class 5 means it is very fraction, milliliters. So it is very severe shut-off condition. These are special valves. So similarly, class 6 also will have only bubbles per minute is allowed. These are very severe leakage conditions. So based on your requirement, you have to select which class is applicable shut-off rating. So in this aspect, you have to discuss with the mechanical people also, because most of the designing, sizing also depends on mechanical requirements. Material selection also depends on the mechanical requirements. So this leakage class you have to discuss with mechanical engineer or piping engineer to fix which class. So this class also very important, because if it is a severe class 5 or 6, there is a special requirements of lining and other things. Material is like that. So it depends on the process requirement. So just like that, you cannot select the class. So it will be costly also depending on the leakage class. So you should be very careful while selecting the ANSI class, leakage class.